Alright, let's solve the power of 2 problem on LeetCode. This is an easy problem and it's a good introduction to get into recursion. So let's go through the description very quickly. We're given an integer n and we need to return true if it is a power of 2, otherwise return false. And then they give us the explanation. An integer n is a power of 2 if there exists an integer x such that n is equal to 2 to the power of x. In other words, they're going to give us a value n and we need to find if 2 to the power of some number would give us n. And if that number does exist, then we need to return true, otherwise we need to return false. For example, they gave us n is equal to 1. A number does exist that when we do 2 to the power of that number, we'll get the value of 1. Similarly, n equals to 16. 2 to the power of what will give us 16? 4. So we return true. But here, n is equal to 3. We have to return false because 2 to the power of not a single value would give us 3. So as I mentioned in the beginning of the video, this is a good introduction to recursion. What recursion is when we call a function within itself. So to illustrate, if I did is power of 2 and then I put n within is power of 2, then once we reach this line of code, we're going to return back up here and go through, well, usually or typically we'd have blocks of code here. So after we call the function within the block of code, it's going to go back up here and repeat this or a certain block of code that we wrote. Now you may be thinking, if that's the case, then aren't we just going to infinitely loop over and over and over again? Why won't it won't stop? That's why in recursion we need base cases. Base cases essentially tell our code when to stop, or it keeps telling us keep calling this function until we reach a certain base case. Also, one more thing, if we kept n as it is when we call the function, and doesn't necessarily have to be n, it could be a tree node, recursion is often seen in trees. If we kept it the same within the callback to the function, then it will loop infinitely, so usually we do have to modify the parameter within the callback. Alright, with that out the way, let's actually look at how we're going to solve this problem. So we need to understand a few things. Let's get this out the way. If n is equal to 0, then 2 to the power of what would give us 0? Nothing, right? Because 2 to the power of nothing could ever give us 0. So that's one thing we need to account for. The second thing we need to account for is if they give us an odd number. So if n is equal to 13, 2 to the power of not a single value would ever give us an odd number. 2 to the power of any value is always 1 or an even number, right? 2 to the power of 0 is 1, which is odd. The only time 2 to the power of something would give us an odd number is if it's 2 to the power of 0. But anyways, we're getting sidetracked a bit. As I was saying, if they give us an odd number, which is not equal to 1, then we have to return false. Now, the final thing we need to account for is if n is equal to 1. If n is equal to 1, like I said earlier, we need to return true because 2 to the power of 0 will give us 1, and 1 is the only odd number we can get from 2 to the power of anything. Or not anything, but 0. We just established our base cases, right? If they give us n is equal to 0, then we need to return false. If they give us, if n is equal to odd, and we'll get to that in a moment, we need to return false. And if n is equal to 1, then we need to return true. And obviously we can't check if n is equal to an even number, because not all even numbers are the result of 2 to the power of something, right? If I had 6, for example, 2 to the power of nothing would ever give us 6. So we're not checking if n is even, we're just checking if n is odd, if n is 0, or if n is 1. Now you may be asking, well, what if they gave us in our parameter up here, n is equal to anything, like 6, right? Okay, well, for n equals to 6, none of our base cases are going to be interpreted. That's where recursion is going to come in. But before we get to that, let's establish how we're going to find out if n is an odd or even number. So we're going to utilize the modulo operator. And basically what this does is if we had 32 modulo any number, let's say 2 for now. 32 modulo 2, what's going to happen is we're going to divide 32 by 2. And we're not going to return the result of this division, but the remainder from that division. So in this case, 32 modulo 2 is, 32 divided by 2 is 16, and with a remainder of 0. But if we had 33 modulo 2 would be 16 with a remainder of 1. And if we had 33 modulo 5, for example, 33 divided by 5 is going to be 6 with a remainder of 3. But for this problem specifically, we need to utilize modulo 2. Now we go back to using odd and even numbers. 32 is an even number, so 32 modulo 2 is going to be equal to 0. But 33 is an odd number, so 33 modulo 2 is going to be equal to 1. In other words, any odd number modulo 2 is going to be equal to 1, and any even number modulo 2 is going to be equal to 0. And one more thing I'd like to re-emphasize on is that we cannot check if n is an even number, because if we had 6, 6 is an even number, but 2 to the power of nothing is equal to 6. So our two base cases, if n is equal to 0, then we need to return false. And if n is odd, then we need to return false. If n is equal to 1, we need to return true. So with our base cases out the way, let's just write them down. If n is equal to 1, then return true. And if n is equal to 0, then we need to return false. Or if n is an odd number, so if n modulo 2 is equal to 1, then we return false. Otherwise, we need to call back our function. So finally, how are we going to use recursion to solve this problem? If we had n is equal to 16, if we dissect 16, 16 is essentially 2 times 2 times 2 times 2. So in similar fashion, if we do the opposite, so 16 divided by 2, divided by 2, divided by 2, divided by 2, that's going to be equal to 1. So if we can divide a number continuously by 2 until we hit our base case, which is 1, that means that value is the result of 2 to the power of something. So with that out of the way, all we need to do here is we need to return is power of 2 of n divided by 2. So if we had 16, well, is 16 equal to 1? No, so we skip this, and it's not equal to 0, and 16 modulo 2 is not equal to 1. So we're going to go here and return is power of 2 with 16 divided by 2, which is 8. And then we're going to do the same process until we get back here. 8 divided by 2 is 4. Again, 4 divided by 2 is 2. Again, 2 divided by 2 is 1. And we hit our base case. If n is equal to 1, return true. So we return true. So let's submit our code and see if it works. And there we go. Like I said, it's an easy problem, and it acts as a great introduction into recursion. So I hope you found that video helpful, and thanks for watching.